Hi, students and friends. This is your host and teacher Sayyid Ayazuddin Haider, and you are watching Learn and Teach by Sir Ayaz. So, I was doing the paper 5070, and I was doing summer 23, paper 21, and I'm done till question number 5. So, let's continue from question number 6. This question is about the energy changes that take place during chemical reactions. A. Methane reacts with chlorine to make chloromethane. The reaction is exothermic. CH4G plus Cl2G gives CH3Clg plus HClG. Draw on the axis provided in figure 6.1 the reaction pathway diagram for this reaction. Include labels for the axis, reactants, products, enthalpy change of reaction delta H, and activation energy EA. So here we have to include axis on this diagram. So on x-axis we have reaction pathway. So write reaction pathway here. You can even write time. And on the y-axis you have temperature or energy. If you're writing temperature, then we have to mention centigrade or energy. Energy, it's up to you if you write kilojoule. Now the reaction is exothermic. Remember, in exothermic, the product will be at the lower energy state than the reactants. The product will be at lower energy state than the reactants. So if we have reactant on the left hand side, this will be the product. What are the reactants? We have CH4 plus Cl2 gives CH3Cl plus HCl. So write CH3, CH4 plus Cl2, and on the product you will write CH3Cl plus HCl. Now I'm going to draw the energy hump for this exothermic reaction. This is the energy hump. And you know the activation energy, if it starts from the reactant, this axis reactant, and it will go up. We label it EA. The sign for EA is always positive, whether it's exothermic or endothermic. Now the energy change between these two sides, that is reactant and product side, we call it enthalpy change of reaction or delta H. This must be between reactant and product. This will be the enthalpy change delta H, and sign is minus. Moving to part B. Hydrogen iodide decomposes to make hydrogen and iodine. This is a reaction. 2HI gives H bond H plus I bond I. Calculate the enthalpy change of this reaction. Use the bond energies in table 6.1. This is table 6.1. Here we have bonds H bond H, I bond I, H bond I, and these are the bond energies in kilojoule per mole. So we need to calculate the enthalpy change for this reaction. You know the formula for enthalpy change? I'm writing the reaction here. 2H bond I gives H bond H plus I bond I. You know that delta H will be energy change for reactants minus energy change for the products. So on the reactant side, what we have? We have 2 moles of HI. So 2 will be multiplied by 298. Minus, on the product side, we have 1 mole of H bond H. So we'll write 436 for H bond H plus 1 mole of I bond I, that is I2. So I'll write 151. So 2 multiplied by 298, we will get 596 minus 436 plus 151. Here we will get 6 plus 1, 7. 5 plus 3, we will get 8. 4 plus 1 will get 5, 587. So 596 minus 587 plus 9. This will be the final answer for this question. Moving on to next part of this question. I'm writing the answer here. Question number 7. Methanol, propane 1-ol and propane 2-ol are alcohols. The displayed formula of methanol and propane 1-ol are shown in figure 7.1. Here we have methanol and propane 1-ol. This is figure 7.1. A. State the general formula of the homologous series of alcohols. This will be CnH2n plus 1 OH. B. Propane 1-ol and propane 2-ol have the same molecular formula but different structural formula. 1. State the name given to compounds that have the same molecular formula but different structural formula. You call it isomers or structural isomers. Structural isomers, or even you can write isomers for this. B part 2. Draw the structure formula for propane 2-ol. Now we will need to draw the structure formula. Remember, structure formula is also the condensed formula. In this, you don't need to show all the bonds. So propane 2-ol means OH must be at the second position, and propane means we have 3 carbon. First of all, you should know the formula for propanol. We have 3 carbons, so you'll write the value of N3 here, C3. H2 multiplied by 3 is 6, 6 plus 1, 7. H7OH. This will be the final formula for propane 2-ol. Now I'm drawing the structure formula of this propane 2-ol. We must have H3C bond CH. Now you must have second OH at the second position. So I will write OH in the bracket here. Then we are left with CH3. It must be propane 2-ol. 1, 2, 3. This OH is on the second position. Alternatively, you can draw in this way also. H3C, single bond C, single bond H. Now I'm showing OH here. Now half part of this is shown as displayed formula and other half as structural form. So this will be the final structure formula for propane 2-ol. Both are correct. C. State why propane 1-ol is a saturated compound. It must be containing only carbon-carbon single bonds. So you write contains only carbon single bonds. D. State why propane 1-ol is not a hydrocarbon. Definitely it must be containing other element other than carbon and hydrogen. So you will write contains oxygen also. Contains oxygen also beside carbon and hydrogen. Number E, propane 1-ol reacts in the same way as ethanol. 1. Draw the displayed formula of the product of the reaction of propane 1-ol with acidified aqueous potassium manganate 7. Now, when you react ethanol with acidified aqueous potassium manganate 7, what will happen? It will oxidize this into carboxylic acid. Alcohol plus, this is oxidation, and we'll get carboxylic acid. So ethanol gives ethanoic acid. Propanol gives propanoic acid. Propanol oxidation gives propanoic acid. Now they want you to draw the displayed formula of the product. We need to draw the formula of propanoic acid. First of all, you should know the molecular formula of propanoic acid. In propanoic acid, there will be 3 carbon atoms in all. So the general formula for carboxylic acid is CnH2n plus 1 COOH. The value N must be 2 here because we already have 1 carbon here. So you can't take 3 as the value of N. You have to take 2 instead of 3. So if you take 2, what you will get? You will get C2H. 2 multiplied by 2 is 4. 4 plus 1 is 5. C2H5 COOH. This will be the formula of propanoic acid. Now it's a carboxylic acid. You must have C double bond OOH. So first of all, I am drawing the C double bond OOH. Now I am left with this part. This part I am left with. I am done with this part, COOH. Now I need to draw C2H5 in the displayed formula form. We have 2 carbon atoms. 1, 2. Show hydrogen. 2, 3, 4, 5. The formula C2H5 COOH is fulfilled here. So this will be the final displayed formula of the product obtained when propane 1-ol is oxidized or treated with acidified aqueous potassium manganate 7. Number 2, draw the displayed formula of the product of the reaction of propane 1-ol with ethanoic acid in the presence of a catalyst. Now this reaction is known as esterification. Esterification is the formation of ester when alcohols are reacted with carboxylic acids. So you are reacting propane 1-ol with ethanoic acid. This is propane 1-ol, propane dash 1 dash ol, and plus we have ethanoic acid. The other name for ester is alkyl alkanoate. Alkyl must be coming from this propane 1-ol. So we will get alkyl propyl from propane 1-ol. And from carboxylic acid, we will get alkanoate. It must be coming from the carboxylic acid. And in this case, it must be ethanoate. So propyl, there must be 3 carbon atoms. What you need to do? You simply need to exclude the OH. So this one is the propane 1-ol. 1, 2, 3. These all are hydrogen. And this one is OH. Now I am treating this with ethanoic acid, which will give alkanoate ion in this case. So I am drawing the displayed formula for alkanoate. H single bond O, C double bond O, CH3. Now in this reaction, there is a release of a molecule of water. So these will be removed as H2O. So final formula for propyl ethanoate will be this. You'll draw this in this way. Single bond O, single bond C, double bond O, CH3. This is propyl ethanoate. This one is propyl. This whole group is propyl ethanoate. This whole group is ethanoate. Part F. Methanol is a covalent substance. 1. Draw a dot and cross diagram to show the bonding in a molecule of methanol. Include only the outer shell electrons of each atom. First of all, you should know the formula for methanol. The general formula for methanol, it's an alcohol. So general formula for alcohol is CnH2n plus 1 OH. Here the value of N must be 1. It's math. So you write C1, H2 multiplied by 1 is 2, 2 plus 1 is 3, CH3OH. This will be the formula for methanol. Now I'm showing the key on the right hand side. We have carbon here, hydrogen here, oxygen here. It's up to you whether you want to take dot for carbon, hydrogen or oxygen. For oxygen, I'm taking blank dot. Now we have one carbon atom and 1, 2, 3, 3 hydrogen atoms, and it's bonded to oxygen. Then oxygen is again bonded to hydrogen. Now I'm removing bonds. And now I will show the outer shell electrons only. Outer shell electrons for each of these atoms. Let's start with the carbon. Carbon belongs to group 4. It must have 4 valence electrons. Hydrogen, it has 1 proton number. It must be having 1 valence electron. Oxygen, it belongs to group 6. It must have 6 valence electrons. 6, 4, 1. Coming back to the question. So for carbon, 1, 2, 3, 4. For each hydrogen atom, we need to show 1 valence electron. 1 for this hydrogen, 1 for this hydrogen, 1 for this hydrogen, and 1 for this hydrogen. What about oxygen? I have just told you, it belongs to group 6. It must have 6 valence electron. 1, 2, 3, 4, 5, 6. Now, you can make circles. And this is the circle for carbon. This one must be for the oxygen. So this will be the final dot and cross diagram for methanol. Number 1, state why methanol does not conduct electricity. Conduction of electricity must be related to the movable or free moving electrons. So you can simply write electrons cannot move or are immobile. Electrons cannot move or are immobile. Part G, methanol is used as a solvent. State the meaning of the term solvent. Solvent is a liquid that dissolves a solute. A liquid that dissolves a solute. Next question, question number 8. This question is about electrolysis. A, the table shows some information about the electrolysis of the 3 different electrolytes using graphite electrodes. Complete table 8.1 with the names of the products at each electrode. First, you are having dilute aqueous potassium chloride. Potassium chloride means KCl. and it's a dilute solution. So the product obtained at anode must be oxygen, and at cathode it must be hydrogen. The reason is that both at anode and at cathode, the ions produced are K positive and Cl negative, beside OH negative and H positive. OH negative is below in the reactivity series as compared to Cl negative ion. For H positive ion, it's also below K positive ion in the reactivity series. Or there are other reasons. You can write hydrogen have high ease of discharge and low difficulty of discharge. Reverse statements will be true for both K positive and Cl negative ion. What about aqueous copper 2 sulfate? It's CuSO4. CuSO4 Cu plus ion is below hydrogen, so you must get copper at cathode. What about anode? We have graphite electrode, so you will get oxygen again here in this case. If you have copper electrode, then you will be getting copper at the dissolving of copper anode instead of this oxygen gas. Molten lead to iodide, it is PbI2. There aren't any H positive and OH negative ion because it is not aqueous solution. So you will get iodine at anode and lead at cathode. Part B, the electrolysis of aqueous copper 2 sulfate gives different products when copper electrodes are used instead of graphite electrodes. Describe the observations during the electrolysis with copper electrodes. You can write any two from these, like increase in mass of cathode or pink solid deposits. I will write increase in mass of cathode or pink solid deposits. At anode, there will be decrease in mass. Decrease in mass of anode. Or anode gets smaller and smaller. Smaller and smaller. You can even write color of the electrolyte remain or stays blue. Color of the electrolyte remains or stays blue. Part C. Magnesium is manufactured by the electrolysis of molten magnesium chloride. At the anode, chloride ions react to make chlorine molecules. Construct the ionic half equation for this electrode reaction. So this one is very easy. You simply have to show the oxidation reaction at anode. Chloride ion will be losing electrons to produce chlorine molecules. Cl negative gives Cl2 molecule plus electron. And if you balance the equation, there are two Cl2. We have Cl2 molecules, so you write 2 before Cl negative ion and 2 before electrons. This will be the final answer. Moving to question number 9. Oxides of nitrogen, such as nitrogen monoxide, NO, are atmospheric pollutants. The exhaust gas from a car engine contains 0.002% by volume of nitrogen monoxide. Calculate the number of molecules of nitrogen monoxide in 960 dm cube of exhaust gas at room temperature and pressure. 1 mole of any gas contains 6.02 into 10 raised to power 23 molecules. So first of all, we need to calculate the volume of nitrogen monoxide. And it's mentioned in the question, they are saying 0.02%, 0.00% by volume of nitrogen monoxide in 960 dm cube. So I will calculate 0.002%. 0.002 multiplied by 960 divided by 100. It must be 0.0192 dm cube. 0.0192 dm cube. Volume of NO. Volume of NO. Now I will convert this volume of NO in moles. And you know 1 mole of any gas at room temperature and pressure occupies a volume of 24 dm cube. 1 mole occupies 24 dm cube. So X mole occupies 0.0192 dm cube. So equation will be 24x is equal to 0.0192 or x is equal to 0.0192 divided by 24. So what we will get? 0.0192 divided by 24. 0.0008 moles of NO. Now I need to convert this into molecules. So what you will do for molecules, number of molecules, multiply moles by the number of molecules, Avogadro number. So 0.0008 multiplied by 6.02 into 10 is to the power 23. What we will get? We will get 0.0008 into 6.02. We will get 0.004816 into 10 is to the power 23. Now I will shift this decimal on the right hand side. 1, 2, 3. So it will become 4.816 multiplied by 10 is to the power 20. So 4.816 into 10 is to the power 20. This will be the final answer for this question. B. Nitrogen and oxygen react to make nitrogen monoxide inside a car engine. Construct the equation for this reaction. This is a reaction between nitrogen. Nitrogen exists as molecule form N2 plus oxygen, also in diatomic state O2. We will get NO. Balance the equation, we will get 2NO. This will be the balance equation. Number C. State one adverse effect of oxides of nitrogen as pollutants in the air. Now you can write anyone from these. You have acid rain or breathing difficulties, or respiratory problems. Or you can even write photochemical smog, responsible for photochemical smog. Photochemical smog is produced a mixture of pollutant. It is found when nitrogen oxides react to sunlight. D. Describe how oxides of nitrogen formed in a car engine are removed by a catalytic converter. NO react with poisonous carbon monoxide to make N2. NO is reacted with CO to make N2. Part E. The rate of diffusion of nitrogen dioxide NO2 gas is less than that of nitrogen monoxide NO gas under the same conditions of temperature and pressure. 1. Explain why the rate of diffusion of NO2 gas is less than that of NO gas under the same conditions. Simply, you will relate it to the molecular mass of NO2 or MR of NO. So you write higher MR of NO2. Higher MR of NO2 or lower MR of NO. Number 2, the rate of diffusion of nitrogen monoxide decreases as the temperature decreases, suggests why using ideas about kinetic particle theory, molecules have less kinetic energy. Molecules have less kinetic energy. Question number 10. PVC and polypropylene are polymers made by a reaction called addition polymerization. A, the diagram in figure 10.1 shows the structure of PVC. This is figure 10.1 and this is a diagram of PVC. Draw the structure of the monomer used to make PVC. Now I'm going to pick the repeat unit. You see, these are the repeat units. Repeat unit number 1, repeat unit number 2, repeat unit number 3, repeat number 4. These all are same. So I'm drawing the repeat unit here. Here we have repeat unit. Only one repeat unit is enough to draw the monomer. We are almost there. Now what I will do, I'm making the monomer, erase the bonds on the right and left hand side and make a double bond in the middle, that is between two carbon atoms. This will be the monomer used to make PVC. Part B. Polypropylene is a polymer used to make plastic food containers. The diagram in figure 10.2 shows the structure of polypropylene. Figure 10.2. Some waste polypropylene plastic is disposed by burning. This makes a toxic gas because of incomplete combustion. Name this toxic gas. Very easy, it must be carbon monoxide. Carbon monoxide. Number 2. State one other environmental challenge caused by the disposal of waste polypropylene plastic. Explain how this challenge is related to the properties of polypropylene. Environmental challenge and explanation for this. You can have a accumulation of plastic in ocean. Accumulations of plastics in ocean or landfill. Now, explanation for this, that they do not dissolve in water or chemically unreactive. Chemically unreactive or do not dissolve in water. C. Name one condensation polymer. Draw the displayed formula of the linkage between the repeat units in this polymer. You have to name any condensation polymer, like you have nylon or polyester. Nylon can also be known as polyamide. Nylon or polyamide. And you can write polyester or PET. For polyamide, show the linkage. This must be the linkage for polyamide. And single bond H, single bond C, double bond O, single bond. What about polyesters? Polyester must contain single bond C, double bond O, single bond O, single bond. This must be the linkage found in polyester. Now that's all for this video. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.